Here we go. Okay, today's topic is Lesson 8, Perimeter and Area. What's our objective, class? Get ready?
Perimeter and area.
Perimeter and area. So, quickly to understand the difference between perimeter and area. Perimeter is the distance around the outside. Area is the area on the inside. So, perimeter here, if I started here, I'd count down 1 unit, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units. So, perimeter equals 12 units. Area is the surface on the inside. So, I can say this is 1 square unit, 2, 3, 4, 5, 6, 7, 8, 9 square units, and we use a 2 as an exponent to say square units. So there's a really quick review. I know you guys have probably done this before. All right, let's review perimeter and area of a rectangle. So if we call this length, we call this width. Perimeter is L plus W plus L plus W. Don't forget to go all the way around. Our more simplified answer would say there's 2 L's plus 2 W's. That's perimeter. Area is length times width. What is our area, class? Get ready?
Length times width.
Length times width. So let's practice this problem right here. The small rectangle is 4 yards by 5 yards. So our perimeter, I'm just going to put it right here. Perimeter equals 4 plus 4 plus 5 plus 5. Let's add that mentally. Think. Get ready?
18.
18. What are my units? Get ready?
Yards.
Yards. Very good. 18 yards. One cool way is you can group it 8s and 10. That's how I do. I look for numbers that are like easy to put together. 10 and 8, 18. Area would be length times width, or 5 times 4, which is. Get ready?
20.
20. What are my units? Get ready?
Yards.
Squared. Area is 2 dimensions, length times width, so I have to have 2 units. Someone said, well, why is that? Because I have 5 yards times 4 yards, which is, we know the commutative property. I can rearrange the order to get the same answer. Don't I have 5 times 4 times yards times yards? Yards times yards is yards squared. That's why we square the units. We're going to skip the big one just for time because it's kind of a long lesson. Okay, this is your favorite. I know it is. We're going to find the perimeter and area of this irregular figure. I'm going to make it a little bit bigger. Find the perimeter and area of this figure. All angles are right angles. So 10 by 12 by 6 by. That's the first thing we got to do. So if I know my full length is 12 and my shorter piece is 5, what would this one be? Think. Get ready?
7 centimeters.
Very good. 7 centimeters. 12 minus 5 is 7. So now let's do this piece. We don't know this one, so we're going to look at the big one. 10 minus 6. 10 minus 6. Get ready?
4
centimeters.
centimeters.
Now we are ready to add all the way around to the perimeter. 5. I'm starting here, going to go this way. Plus 4, plus 7, plus 6, plus 12, plus 10. Add them in groups. This is my fast way to add. There's 9. There's 13. There's 22. There's 22. There's 44.
Wow.
Isn't that a cool way to add really fast? I didn't have to stack them up like that. Okay, let's do area. Area, wow, it's irregular though. I can't do a length times a width. Jasmine?
You just put a line.
We're going to do that. Put a line, we're doing, we go down or across?
Me just being me, I would go across.
I would go across too, for some reason it just feels better.
Feels right.
Now I got to do each area separate. So I'm going to do length times width, 6 times 12. Think, you guys do 6 times 12 mentally?
Yes.
Ready?
72.
Awesome. What are my units? Get ready?
Centimeters
Squared. Squared. Because it's area, it's 2 dimensions. Centimeters times centimeters, centimeters squared. Okay, how about this one? 4 by 5, think. Get ready?
20 centimeters
Oh,
squared.
I love it. You guys got the units right off the bat. So my area, area right here, 20 plus 72. Now, last year I had some students that wanted to times 20 times 72. That would make sense, right? They knew that area was, times something. Well, we already did. We times these, Now we need that, and is add. 72 plus 20 is 92 centimeters squared. There's our perimeter and area. Give me a thumbs up if I'm feeling pretty good about perimeter and area. Give me a secret thumbs down if you're like, I have no idea what you just did. Okay, we're good. All right. Let's go on to draw a line. We're going to go to lesson number 9. We're going to talk about prime numbers. What's our objective, class? Get ready?
Prime numbers.
Prime numbers. We're also going to talk about prime factorization and composite and some divisibility. But the main thing you need to know out of lesson 9 is a prime number is a number that's only divisible by itself and 1. That's a prime number. It's only divisible by itself and 1. What is that called, class? Get ready?
Prime number.
Prime number. Let's make sure everyone's responding. What is that called, class? Get ready?
Prime number.
A prime number. So let's give an example. How about 7? 7, there's no factors. The only thing that would divide into 7 is 7 and 1. So therefore, it's prime. A composite number would be a number that has factors, like 6. Okay, 6 is even, so 2 would go into it. 2 would divide into it. 2 and 3, 6 and 1. So 6 is composite. A number that has factors is called composite. What is it called, class? Get ready?
Composite.
Composite. So we're going to do a list of the first 10 prime numbers to get you really thinking. And I'm just slide it up just a little bit. All right. Now, the number 1, you think, well, nothing goes into 1 but itself, but that's an exception. Someone decided a long time ago, we don't want to count 1, it's boring, we don't care about it, so we're going to start with 2. So 1 is not a prime number, but 2 is, because the only factors are 2 and 1. How about 3? Yes or no?
Yes!
Yes, 3 is prime because there are no factors. How about 4?
No.
No! It has factors, so it's not a prime number. How about 5?
Yes!
6?
No.
No. 7?
Yes.
Yes. 8?
No.
No, it's an even number. 2 will divide into it, so it's not prime. 9?
No.
No. 3 and 3 go into 9. 10?
No.
No. 11?
Yes.
You just turned right. 11, there's no factors, so it's prime. 12?
No.
13?
Yes.
14?
No.
15?
No.
Someone was not sure. 15's got 5 and 3. Okay. How about 16?
No.
No. 16 has 4 and 4. 17?
Yes.
Okay. Let's do one more. 18?
No.
19?
Yes.
Yes. 19. Are there any factors that go into 19?
No.
Do we have 10? 1, 2, 3, 4, 5, 6, 7, 8. Oh, we need 2 more. How about 20?
No.
21?
No.
22?
No.
23?
Yes.
You guys got this last one. 24?
No.
25?
No.
26?
No.
27?
No.
28?
No.
29?
Yes.
Oh my God, there's like this huge jump right there because all the numbers between them have factors. You are now professionals at prime numbers. Why do we care? Because that movie Contact with Jodie Foster and Matthew McConaughey, remember that one?
Matthew McConaughey.
Back in the 80s, the late 80s?
What is it called?
Contact.
I remember.
Contact?
You showed us the video last year.
I
It was
showed
them
you the video.
talking in math because it's a universal language.
So what happened, what did it have to do with prime numbers in the movie Contact?
I have no idea.
That's how the aliens
Yeah, this is
contacted Earth. They sent pings in rhythms of, they sent 2 pings, 3 pings, 5 pings. And that's how the aliens contacted. And that's how Jodie Foster figured it out. She says it's mathematicals because it's the only pure language that everyone speaks. You don't have to speak alien language to understand this. It's kind of cool. All right, we're going to skip that. Prime factorization. This is the cool one that students really like because you make an upside down tree. We're going to break down 36 into its factors and keep going until the very bottom numbers are the smallest prime numbers possible. But I need to recapture you. I'm losing some of you. So show me and say slant.
Slant.
There we go. That's our position. eyes are up there, very nice. Okay, factors of 36. My first thought is, oh, 9 and 4. So then what are the factors of 9? I say 3 and 3. The factors of 4 are 2 and 2. Then I go, are there any more factors of 3?
No.
No, so it's prime and I circle it. 3 is prime. Is 2 prime?
Yes.
Yes. Is 2 prime?
Yes.
But I'm not done. I have to give an answer now. So what is my answer? I write it in least to greatest with times symbols and box my answer. 2 times 2 times 3 times 3. If you show me this on your whiteboard, I'll say no. If you show me this, I'll say correct. Yes, technically, but we don't have that lesson for like a few more months. But nice job, Colin, that you know that. We're going to skip 45 because I'm going to let you do a practice one and a practice set, but we're going to talk about divisibility. Well, suppose you had a really big number like this, and someone said, factor that for me. What numbers go into that? It could take a while to check and do all that long division, so there's a shortcut. We love shortcuts. So I'm going to shrink it down a bit. All right. This is the divisibility test. If a big number like this is divisible by 2, you look at the last digit. If it's even, it's divisible by 2. Is it divisible by 3? Here's the cool trick, and this is one of the weirdest math phenomenons. It's like, I don't know why it's like this. It's weird. But if you add the digits, 1 plus 2 plus 3 plus 7 plus 5 plus 2 plus 6, and if that number is divisible by 3, then the whole number is divisible by 3. It's really weird. So let's add that. Stay with me here. 1 plus 2 is 3, plus 3 is 6, plus 7 is 13, plus 5 is 18, plus 2 is 20, plus 6 is 26. Is that divisible by 3? Yes or no? No. Okay. Is it divisible by 5? The last digit? No, it has to be 5 or 0. Is it divisible by 6? The rule says if it's divisible by 2 and 3, it's not. So it's not. Divisible by 9, this is another weird thing. If the sum is divisible by 9, it is, but is it?
No.
26 is not divisible by 9. And then here's another really weird one. Actually, it's not super weird. You take whatever the last 2 digits are, and you see if that's divisible by 4. Is it divisible by 4 without a remainder? No. So that's a quick way to check for divisibility. You don't need to memorize these. There's a table, like on a test. I wouldn't expect you to memorize them, but there's a cool way to do a big, huge number.